This is a discussion of changes of matter. Changes of matter follow two basic laws: the law of conservation of mass or matter, and then the law of conservation of energy. Both of these laws are followed for all changes of matter, both physical and chemical changes. Now, we're going to find out that chemical changes typically involve greater changes of energy, and therefore they're more difficult to undo. Um, so when we say change of energy, though, we mean like transferring energy from one substance to another, or one form or another. And then physical changes and chemical changes are always going to have the same mass before and after, just sometimes the mass changes form. So for example, you might start out with a liquid and a solid, and you mix the two together, a gas forms, and then the mass would appear to be lighter. However, the mass might have changed into a gas, which is harder to collect. So law of conservation of matter, LCM, law of conservation of energy, LCE, both are followed for both physical and chemical changes. So chemical change is going to be a change of matter that produces some kind of new material, which will have new properties. And that's how we're often going to determine if a chemical change occurs, is we're going to look for some of those new properties. If you have formation of heat or light, if you make a gas, if you have a color change, or if you form a solid, those are often indicators of a chemical change. Look for these words that are on the screen: burn, rust, corrode, tarnish, oxidize, cook, decompose. Those are common words that mean that a chemical change is going to occur. And then when you're testing for this, if you're presented with, is this change physical or chemical, ask yourself questions like this. Is this difficult to undo? Did a new substance form with new properties? Specifically look for new intensive properties. And then finally, could I write a new formula for whatever is created? Did the formula stay the same or did it change? Chemical changes are also interesting for us because those are chemical reactions. So much of what we discussed this year is going to be chemical changes. Contrast that with a physical change, which is changing just the state of the matter, the form of the matter. So we might be freezing some water, or we might be condensing steam back into liquid water. We could be taking a piece of paper and folding it, or cutting it, where we still have paper, we still have water. We're just changing how it appears on the outside. So look for words like tear, grind, melt or freeze, boil or condense, bend, cut, etc. Ways to ask yourself if you're presented with, is this change physical or chemical? Is this the same substance? Is this a different state of the matter? Like, is it solid compared to liquid? Or is this the same formula, just in a different way to look at that substance? So then I have a couple of examples I'd like to show you. The first one I'm going to show you is, the first example I'd like to show you is I have two different solids. They're both inside little weigh boats. And I could add water to each of these. And this would just be dissolving the solid into water. Dissolving is a physical change because both the water and the solid are still present in their initial containers. It's just that now the solid particles have gotten smaller. Okay, so some of that solid has dissolved, not all of it has dissolved. But you can see that the shape or how the solid looks has changed. We can no longer see it. The particles have gotten smaller. So sometimes it seems like a chemical change may have occurred because it's now gone. We do still have two colorless and clear solutions that are formed. So this was a physical change. If I were to evaporate the water, I would get all of the solid right back. But if I mix these two together, a brand new substance that happens to be yellow has formed. Brand new substance there. This substance has new properties. It's yellow, it's a solid, and that's going to be a chemical change. It would be very difficult for me to undo that chemical reaction. Another example would be a piece of paper, just a white piece of paper. We could fold this paper, we could crumple the paper, we could tear the paper. In all cases, I still have paper. It's just that I've changed the format of that paper. It's still paper, it would be hard to put this paper back together. You can use tape to do that, but the important thing is that all this paper is still paper. We haven't done anything to change the identity of this. So this would be a physical change. If I were to take a lighter and light the paper, I'm making a new substance, making some gases, making smoke, making water vapor. This I would not be able to undo. That would be a chemical change. One other example would be taking a piece of copper wire. I can bend the wire. I could cut it into smaller pieces. I could twist it. I could just warm it up in some warm water. These would all be physical changes because I still have a piece of copper wire. However, if I take this shiny piece of copper wire and I were to, again, add some heat to this, the copper wire is going to oxidize and actually make copper oxide. And now we have a color change. On the end of this piece of copper is a completely new substance that has different properties. It's no longer the shiny light brown. It's a dark brown, maybe even black. And it's actually a compound. It's no longer an element anymore. So those are some examples of physical versus chemical changes. You're going to be asked to do worksheets that asks you, is this a physical or chemical change? And we have those tests. Did something new form? Is it the same formula? Is it easy to undo this? So if I take sodium chloride and dissolve it in water, I'm not making anything new. I'm just making those sodium chloride crystals get smaller. This would be a physical change. I could easily undo that by evaporating the water. Milk souring. That'd be very difficult to undo. You've made a new substance with new properties, the stinky milk. Silver tarnishing. The word tarnish is one word that means react. It's kind of one that you need to either have some prior knowledge about or need to memorize the word tarnish as being chemical. Sugar dissolving water, very similar to question number 1. That's a physical. It could just evaporate the water. Cutting an apple. I still have apple. It's just in 2 halves. So that's physical. Wood rotting, that's a form of decomposing. I can't undo rotting. That's a chemical reaction, chemical change. Heat changes water to steam. I would still be able to represent steam as H2O. It's just now gaseous H2O, so that's a state change, which is a physical change. Anytime we use the word cook, that's going to be a chemical change. It'd be hard to take that pancake batter and switch it, or excuse me, that pancake and switch it back in the batter. It also has new properties. Pancake batter by itself would be pretty disgusting, but a cooked pancake normally tastes pretty good. And then lastly, baking soda reacts with vinegar. Again, you might need some prior experience to understand that, but hopefully you would know that a gas forms, and a gas wasn't present prior to mixing those two, so you've made a new substance. That's a chemical change. Also, keyword there, the word react. So you might need to memorize some words. That's what makes this unit so hard is memorizing words like rust, tarnish, corrode, etc. means chemical reaction, and then things like boil, melt, condense, dissolve, separate, a mixture, all mean physical change.